My name is Mark Murphy, and let me get the screen set up. You should hopefully be now seeing also the title slide. What to expect when you're expecting Jetpack Compose, the topic of today's presentation. You might know who I am from a seemingly endless series of books that I keep writing, and that including elements of Kotlin Coroutines version 0.2 out yesterday. You might know me from a handful of answers that I've posted out on the Stack Overflow. You might know me from past presentations in the Boston area. You haven't been there in a few years, and that hopefully I'll get back someday. You might know me from training I've delivered in Mississauga or Waterloo in past years. And if not, that's okay. And I'm just here to talk to you about Compose. Compose itself. We got wind of this at Google I/O last year. They said, all right, Jetpack Compose, it hid it behind some obscure session title, and that they gave us the first, developer releases of it, in the fall. And this is a new replacement UI framework. Widgets, fragments be gone, and that is being replaced with a reactive, declarative sort of setup. We'll be looking at some code, not a ton, mainly because this is changing fairly rapidly. By the end of this presentation, this code probably won't compile anymore, and that because there's going to be a new Jetpack Compose version, and it's going to be all different. So it is, but the idea is that this is apparently Google's long-term direction in terms of where the UI is going to go. That they're going to try to back us away from framework declared views tied to device manufacturers, and that lead to a library that they can rev, and that it has a modern, clean API. Right now, as I said, we're in a developer preview mode, and that the API surface changes, and that with some frequency. Just last week, when the Android 11 announce event, whatever that wound up actually being called, in a presentation, Roman Key said that we've got a timeline now that summer of 2020 is going to be when the alpha is out. Didn't specify what hemisphere, and so I'm assuming it's Northern Hemisphere, and so it'll be out here within the next few months. And 2021, and that is going to be, supposedly when we will get a stable release, and obviously there will be a beta somewhere in between. The way that Jetpack Compose is set up is that it is all function-based. In fact, a lot of their samples and that are focused on top-level Kotlin functions, and that not even necessarily inside of some class like an activity. They all get this composable annotation. New story as a function is a composable, and it turns around and calls a whole bunch of other composables. Column is a composable that sets up a column. Image is a composable that shows an image. Height spacer is a composable that adds some vertical white space. Text is a composable that you get the picture. And so we describe the UI that we want, but these aren't creating, they're not returning anything. Column is not returning something that we're using. Image is not returning something that we're using. Instead, behind the scenes, a Kotlin compiler plugin is stitching all of this together into basically a hierarchy of what it is that we're describing the UI to be. Then, inside of your activity, you can just use the set content extension function to say, all right, let's set the content view of this activity to be the UI set up by news story, and it's going to call that function. You will be able to hook this up to view groups. From there, you can hook up to fragments and so on in order to be able to go in and get your UI out to wherever it is you want. And long-term, the vision is that you would get rid of the fragments and replace them entirely by composables. We'll look at some more elaborate samples coming up in a bit, but I just wanted to give a little bit of a hint as to what the syntax looks like. If you've been paying attention to Compose, this is nothing new. Now, we just went through a significant overhaul of Android. We got the Jetpack, series of libraries overall, and there was that little Kotlin thing that came out. And you probably remember how all that went. 2017, and that the Google's asking, hey, you interested in this Kotlin stuff? And that the show of hands, at IO or Android developer summits and so on. 2018 IO, we support Kotlin. 2019, we are Kotlin-first, and that their focus is on Kotlin, and Java is going to be somewhat more of a second-class citizen. But we still support Java for a while. Technically, they're going to have to support Java indefinitely, but you're going to need to go in and realize that, okay, from a language standpoint, yes, you can use Java, but a lot of the libraries are going to be Kotlin-centric. They're going to be using coroutines. Jetpack Compose is using a Kotlin compiler plugin. Java is going to be further relegated to the backwater. If you have questions, by the way, as you go along, pop them into the Q&A section here in Remo, and we'll try to get to them towards the end. So, hiring Android talent, hasn't exactly been easy in recent years. This year is a little weird, for a whole lot of reasons. But over the past few years, trying to get Android developers, and that has been a little bit difficult. And if your organization is viewed as being behind the curve, that makes it that much more difficult. If you're a Java-centric firm today, you may already be starting to have some challenges in trying to land new talent, because developers are going to look and say, okay, well, it's clear that Android is fairly heavily moving in a Kotlin direction, and that if you're going to be going in and saying that, all right, we're still doing Java here, are you going to have trouble being able to pull in that talent? If Google is backing Compose the way I'm expecting, we're going to get a similar effect from that a few years down the road. So 2021, when Jetpack Compose ships, is going to be a little bit like 2018, from a Kotlin standpoint. By 2022, 2023, there's going to be a fair amount of momentum in the direction of Jetpack Compose if everything is going as expected. And is that going to then be a problem if you're not there? And so the point of this presentation is to try to figure out, okay, what should you be doing now, perhaps to prepare for that sort of a future? Because, if you've gone through that whole Kotlin migration, you remember how that went. There was a reasonable amount of work involved depending upon the size of your project. Compose, migrating to that is going to be narrower, yet more complicated. By narrower, I mean less of your app is directly affected. If you're using, Google's recommended architecture, and you've got like repositories and data sources and maybe use cases, none of those are likely to get affected by a move to Compose. View models will get affected. Activities fragments, oh yeah, they're going to get affected a lot. If you're using custom views, oh yeah, they're going to get affected a lot. So the surface area of Compose's impact is going to be smaller, whereas Kotlin, in principle, would affect your entire project. But it's going to be a lot more involved, and probably not as great a tool support. We got lucky in that we were able to get the Java to Kotlin conversion wizards. There will be some amount of tool support, but I would be very surprised if it's going to be as smooth as the tool support for Kotlin. And even that, you did the automatic conversion, and then there was still some amount of cleanup to get idiomatic Kotlin out of the conversion, and something that you would be willing to look at and have reviewed in a PR and so forth. And so the more you can kind of think now of, okay, how should we be factoring Compose into our decision making so that 2 years, 3 years down the road, you're starting to migrate into Compose, that you've laid a little bit of the groundwork for it. That's what this is all tied into. So what we're looking for is to minimize the pain of that transition, and that without a lot of prep work that maybe isn't worth it if Compose doesn't pan out. Not everything that Google does ends up really mattering much. A couple of years ago, slices were the big thing that Google was touting at Google I/O. I gave a presentation on slices, and I deeply regret it, and because I wasted 40 minutes of a whole bunch of people's time, because slices never really amounted to a whole heck of a lot. And could Jetpack Compose go the same way? Yeah. Is it likely? No. I think, have invested a lot more into Jetpack Compose than they ever did into slices. And so it is likely to become a real deal, but Google has a long history of canceling stuff, and so we can't completely rule it out. The other thing is, how can we leverage both maybe Compose itself and the overhaul of the UI to turn around and improve the apps in other ways? And because from the user standpoint, Compose is a lateral move. It's not like the user is intrinsically, because we're using Compose, all of a sudden going to get this awesome experience. Just because we're using Kotlin, they're not going to get this awesome experience. This is all inside baseball to us, and it's improving our ability to deliver product, but it is not really user facing. And so what can we be doing to make the user experience better? As opposed to, or in addition to, just focusing on our, what it means to us technically. So obviously, if you're going to be using Jetpack Compose, you're going to be needing to think heavily about Kotlin. Many of you probably are already on pure Kotlin projects. Some of you are probably on a split, some that's been migrated to Kotlin, some still in Java. Some of you may still be on Java projects, and sorry, and you're going to have some of the roughest haul, and because Compose, like I said, it relies on a Kotlin compiler plugin. There's a lot of things in Compose that are only possible because a compiler plugin is taking what you type in and changing it under the covers into the Kotlin that actually winds up getting compiled. For example, with those composable functions, there's actually a whole bunch of additional parameters that get passed on those. You don't ever see them unless you're using reflection, but they're there, and it's the Kotlin compiler plugin that's giving them to you. Java interop, therefore, is going to be a challenge, and it's not a primary focus of the Jetpack Compose team, and so you're going to be having some challenges in getting your Java code to be able to integrate with your Compose-based UIs. And of course, 2022, 2023, we are that much further removed from Google going Kotlin first, and that the Java is going to be kind of tech debt, and that by that point in time, and that in the eyes of a lot of recruits, a lot of candidates for your positions. And so you need to be thinking about, okay, can we get over to Kotlin entirely here within the next few years if you're not there already? Layouts. You'll notice that in that code snippet that I showed you, there wasn't a layout resource. And that those layout resources are getting replaced by basically functionally equivalent Kotlin code, and creating composable functions. And so in the near term, it's not like you need to get rid of layout resources. You probably can't get rid of layout resources, but what you can do is try to streamline them, and try to clean them up, get things into styles, themes, dimension resources, that sort of stuff that you might have already just hard coded into the layouts. Those things still have roles in Compose, and we're still going to be able to reference those sorts of resources and be able to use them either directly or through third-party libraries. Google's Chris Baines, for example, created Accompanist, a grab bag of various Compose utilities, one of which says if you've got a theme set up for the material design components, it will automatically adapt that and let you use that as a theme for your Compose stuff. And so if you've got themes that are set up for tools or libraries to be able to use, that bit of migration will be that much cleaner. Since the layouts are going away, the less we have in the layouts, the better off we're going to be. And that then leads into data binding, or possibly data binding. and that's intrinsically tied to layout resources. And therefore, since layout resources are going bye-bye, so is data binding. And so everything that you are relying on data binding to perform for you is going to wind up getting moved into some Kotlin code somewhere along the line. The more binding expressions you've got, the more of that you're going to need to deal with. This doesn't mean you have to rip out data binding today, but it does mean that, all right, if you haven't really made the move into it, this would be an argument for maybe not doing it, or slowing its pace down, and so that you don't wind up making that portion of the migration that much more of a challenge. So let's take a look at a little bit more code. Here we have a data class called agreement view state. This is for a form, and where maybe you, in addition to this form, you are presenting some various legalese that the users got to agree to. And so there is a terms and conditions, and there is a privacy policy. And you want them to check a couple checkboxes to say that, yes, they have read and agreed to these things before continuing. And so we've got a can proceed function that simply is looking at those two values and determining whether or not we're able to go along. Inside of this agreement composable, then I have a state declaration. State works a little bit like bylazy. It's not strictly a property delegate, but it looks a little bit like it insofar as this Lambda expression is going to get evaluated the first time this composable gets called. And so I create an agreement view state where both terms and privacy are set to false. That's then held on to, and I can reference it. Inside of a checkbox widget, I can indicate whether or not it's checked by grabbing the value out of this state, specifically the terms for this particular checkbox. This is for the terms, and I set the checkbox to be checked based upon that view state. On check change, we get the callback to say, hey, the user clicked on it. We can then turn around and mutate that view state. We go in and we are copying the existing value, flipping the terms to be whatever the checkbox is set it to. In Compose, widgets are stateless. We're used to checkbox views having an intrinsic knowledge of whether or not they are checked. And we have to keep synchronizing that with our models or other stores of data. In Compose, these are stateless. User checks this checkbox, that checkbox isn't changing unless we go in and change it. But what happens is that when we go in and we update this view state, Jetpack Compose, courtesy again of that compiler plugin, says, oh, you changed this state. We need to re-execute this function in order to be able to turn around and re-render it. And so it's going to, when it re-executes the function, the view state value will now be the new terms, and the checkbox will reflect whatever the user did, whether it is now checked or unchecked. And Jetpack Compose, even if this is one little corner of a larger hierarchy, Jetpack Compose knows what portions of your UI are affected by this state, which function or functions need to get reevaluated. That not only can affect the checkbox, but here I've got a text where the text that is being rendered is based upon that can proceed function. If we can proceed, we show one message. If we cannot proceed, we show another message. And so hopefully now you are seeing a live view of a Pixel 4, and that I've got this form up, and that we've got the checkboxes. I check the checkboxes. You may proceed, and that the swaps in from what had been please indicate your agreement. I am not telling that text view, please change. I am reacting to the fact that the state has changed. This function gets recalled, and we swap in the different text based upon the value of can proceed. Let's look at an even more elaborate example. Now you should be seeing a copy of Android Studio 4.2 Canary 1. Once again, we've got the agreement view state, and that pretty much the same as it was before, though I switched it here to be a computed property. Now we've got a view model, standard Jetpack view model, and that where we've got live data, standard Jetpack, live data, immutable live data, which hold on to the current agreement view state and make that available. We've got functions here to mutate it, grab the current value out of there and modify it to be reflecting of the new check state of the checkbox. Now, view state is working with that view model. We're getting the state's live data from that view model, and observe as state is a new extension function provided by Jetpack Compose that basically allows us to feed live data into these composables as state. And so we still can reference that state, get the terms, privacy values, and that see whether or not we can proceed, and use that to render our UI. And as soon as live data emits a new value, Compose realizes, oh, wait, we're using that here. The agreement is going to turn around and need to get reevaluated, and we're going to re-render this block of code. So, what's all that mean? This is perhaps going to have some impact on your architecture, and that for whatever you're using, MV soup, and that pick your soup, and that the big thing that Compose is aiming for isn't necessarily any specific MV flavor or Viper or whatever other architecture you want to use. Its focus is primarily on unidirectional data flows, however you want to organize that. State tends to flow down. And so we've got view models, other high-level stuff that's calling functions that are parceling out bits of state that those functions need to be able to render themselves, where all of that stuff is reactive, and so that those functions can get re-executed, re-render those portions of the UI when needed, and events flow up. There's going to be a whole bunch of Lambda expressions or other function types that you're going to be passing around so that you can pass handlers down the click events and whatnot from the individual composables, and that you can call those handlers to ripple up to turn around and affect your state. As I mentioned, the widgets themselves are not stateful. You're not having to worry about trying to copy values out of the edit text and put values into the edit text the way we do today, and deal with all the headaches of, oh, wait, what about configuration changes? Oh, wait, what about saved instance state? Why is my saved instance state clobbering this other thing that I'm trying to do? That sort of deal. And so those sorts of things are going to perhaps impact the way that you are organizing your code in terms of, what are the roles of the view models? Are you using presenters? Where are those roles going to be today? And that sort of deal. And so you're going to want to be thinking through here over the next period of time of how you're going to want to address those things. By cleaning up your architectures, one of your objectives probably ought to be settle on one. And that it will be easier for you to be able to migrate if you are only trying to migrate one pattern rather than trying to migrate several patterns, all of which need to be individually decided. Okay, how does this translate into the world of Compose? Maybe today you are already supporting landscape. You're probably in the minority. Apps don't support landscape today. Is this an opportunity for you to take it, decide, okay, hey, maybe we should support landscape now. Maybe we can support dark mode now. Maybe we can support split screen now. All these things that Google has been begging developers to do that, we haven't been doing as much. And that maybe this is the supportive deal sort of thing that you can look to add in. You might even look at bigger ticket things. What are the things that Compose are going to enable that maybe weren't realistic previously? And that things that might be more game changers for your organization. The one that I'm keeping an eye on is the UI desktop module. JetBrains, in conjunction with Google, is working on taking Jetpack Compose, tying it in with Kotlin multi-platform, and making it available on the JVM for Mac, Windows, and Linux. And so the question then becomes, okay, well, if we can take Kotlin code with Jetpack Compose and be able to render our UIs on the desktop, Is it realistic that could we possibly, create the whole app and migrate other logic into the Kotlin multi-platform space, and that in order to be able to get our app onto the desktop where your app might not be today? Won't make sense for all apps. Some apps, it might be useful. As the months go by, keep tabs on where Compose is. By the time it's getting to beta, my guess being early next year, and that ideally budget some time to start playing with it. Not necessarily even in your own main project, and that have side projects, and that you're kicking the tires on the APIs, getting a feel for how this is going to work. How could you do a UI akin to this thing that you have in your app, and that using Compose? Partly, the idea here is that you want to be able to use that knowledge to be able to further steer your plans in 2022 and beyond. Partly, it's so that you can help steer what we as a community, all untold, need in order to make all of this work. So as you're finding problems, as you are coming up with ideas for tools, libraries, etc., tell people, and that whoever you want to tell, wherever you want to tell, get the word out, and that so that maybe your idea of an itch somebody else decides to scratch, and or somebody knows of somebody else who's already scratching it. You're going to then, as you probably had to do with Kotlin, and that the convince management that yes, it is worth the engineering time in order to make the migration. So, make sure that you've got your rationales lined up for why are we doing this stuff? How is it going to impact what we're doing, on a day-to-day basis? Are we going to be able to, continue to meet deadlines while doing this sort of conversion? How are we going to do it? Are we going to do it all in one shot? And are we going to do it screen at a time, activity at a time? What's the granularity of the changes? Bear in mind that there's going to be a hype train around this, just as there was a hype train, with Kotlin. And that you're going to find that, everybody's talking about Compose, and that Google's going to be touting it at all of their events. And that you'll make tons of Medium posts and whatnot, and that and Compose is going to be awesome, and that but it's also not the sort of thing that you need to rush into. It's the sort of thing that we want to be able to support someday. You want to plan for how you're going to be able to support it someday, but it's not like the day it ships stable that you got to start moving, and that come hell or high water, and that think through what the ramifications are going to be, play with it, figure out what the plan is, and that convince management, and that this is a good idea, and then move forward from there. And with luck, your Compose migration will go as smoothly as your Kotlin one did, or maybe better, depending on how all that went. That wraps up the presentation itself. I will paste this into the general chat if you want to grab a copy of the slides, and that tiny little Compose project. Again, bear in mind you're going to need 4.2 Canary 1, and with that, I've got a few more minutes, I think, so I'll take a few questions. Oh, Jeff, hey, do I have time for questions?
Yes, you do. I just wanted to confirm and not just you talking into the ether with wonder. First of all, thank you so much. Everybody loaded a sound effect thing on my phone to play into my speaker, but everyone, I can't give you a round of applause, but that was an amazing talk. Thank you so much for taking the time to present to us. Yeah, I feel like, how about just the top 3-4 questions, whatever works. Let's get this show on the road, though. Your discretion. Thank you.
Okay. Top question, and where does something like 16DP get the reference to the context from? Yeah, good question. The Jetpack Compose has a concept of ambience. It's not exactly a global hash map, but for the purposes of this conversation, we'll go with that. And so there is a context ambient, and that ripples down through the whole composable hierarchy. And so that .dp extension function on int to be able to convert a pixel value into, or basically set this up as a DP object, and that is basically going to be tying into perhaps that context ambient. Really, though, the .dp extension property is creating a DP object. DP is literally a class inside of Kotlin. I think they're hopefully going to make it an inline class when that becomes stable. And so we're actually now, not just having just bare ints and having to remember whether this is pixels or dips or whatever, and that's the actual typed dimensions, and that they are first class objects in the system. Is there any changes to testing? Of course, we don't got widgets no more, and so something like Espresso that is heavily widget based, and that there's going to be a new take on it. And that there is testing code out there, and that there's a ton of samples in the I guess it's AOSP, but the Jetpack Compose repositories, they are exercising that testing code as part of their own work, because again, this is all a library, and so while it is part of the AOSP tree, like a lot of their other libraries, they are working on it much the same way as we would. Not a whole lot of docs around that testing code yet, but I'm sure that will come in time. But yeah, and that anything that your UI testing, if you are relying on Espresso or you are otherwise, UI Automator and that for your own widgets, that sort of thing, yeah, there's going to be changes, and I'm sure there's going to be changes on top of the changes, and that given the pace of Compose development. Are there any tips and tricks for saving view state across process depth with Jetpack Compose? And that my guess is that they are going to be steering you in the direction of view model and save state handle, and that they haven't really been talking a lot about that. They have said that they are hoping that configuration changes basically go away to an extent, and that you're going to have greater carte blanche to go in, add in the manifest entries, Android config change, and opt out of a bunch of them, because that's all going to get handled inside of a Compose framework. It'll detect the configuration changes and recall your composables as needed. But in terms of saved instance state, and that my guess is they're going to steer us in the direction of view model, and but they haven't really said that I've noticed. One last one. Can I call a composable function in a different file class? Absolutely. And that no different than anything else. And that if it's visible to you, you can call it. And that some things do get weird. I've been playing with reflection. That's a little weird. And so there's going to be some edge cases, but there's composable libraries, all those functions like column and row and checkbox and text that I was calling, those all come from libraries, and that I'm calling those no differently than anything else. We'll be able to publish libraries of composable functions much the same. And with that, I think we'll wrap up my portion of this presentation.